far beyond the familiar stars we see in the night sky. The universe stretches into unimaginable distances. Billions of galaxies drift through the darkness, each containing billions of stars, planets, and cosmic mysteries waiting to be uncovered. For centuries, humanity has wondered whether life exists somewhere beyond Earth. Are we alone in this vast universe? Or are the building blocks of life scattered across the cosmos? Today, powerful telescopes are beginning to answer that question. And recently, one of the most advanced observatories ever built has made a discovery that surprised scientists around the world. The James Webb Space Telescope has detected organic molecules inside a distant galaxy, where scientists never expected to find them. This discovery is not evidence of life itself, but it reveals something equally fascinating. The chemical ingredients that help create life may exist far beyond our own galaxy, hidden within the ancient light of distant cosmic structures. To understand why this discovery is so important, we first need to understand the remarkable machine that made it possible. The James Webb Space Telescope is the most powerful space observatory ever launched. Built through an international collaboration between NASA, the European Space Agency, and the Canadian Space Agency. This telescope was designed to look deeper into the universe than any telescope before it. Launched in December 2021, Webb began its journey by traveling nearly 1.5 million kilometers away from Earth to a special location in space known as the second Lagrange point. From this stable position, the telescope can observe the universe without interference from Earth's atmosphere or the heat of our planet. What makes Webb so powerful is its ability to observe infrared light. Unlike visible light, infrared radiation can travel through cosmic dust clouds that normally block our view of distant objects. This allows Webb to see structures hidden inside star-forming regions, distant galaxies, and the earliest moments of cosmic history. In many ways, Webb is like a time machine. Because light takes time to travel across the universe, observing extremely distant galaxies allows scientists to see them as they existed billions of years ago. Some of the galaxies Webb observes formed when the universe was only a few 100 million years old. Studying them allows scientists to understand how the first stars and galaxies were born. But Webb is capable of much more than simply taking pictures of distant objects. Using advanced instruments, the telescope can analyze the light coming from stars, planets, and galaxies in extraordinary detail. This technique is called spectroscopy. When light passes through gas or dust, certain wavelengths are absorbed or emitted by specific chemical elements and molecules. By analyzing these patterns, scientists can identify exactly what materials exist inside distant cosmic objects. It is through this technique that Webb made its surprising discovery. While studying a distant galaxy, astronomers noticed something unusual in the galaxy's light spectrum. Embedded within the infrared data were signatures of complex organic molecules. Organic molecules are chemical compounds that contain carbon atoms bonded with other elements, such as hydrogen, oxygen, nitrogen, or sulfur. On Earth, these molecules form the basic foundation of life. Proteins, DNA, and many other biological structures are built from organic molecules. But these compounds are not limited to living organisms. They can also form naturally in space through chemical reactions within gas clouds, dust particles, and the debris left behind by dying stars. For decades, scientists have detected simple organic molecules in interstellar clouds inside our own galaxy, the Milky Way. Some of these molecules include methanol, formaldehyde, and even more complex carbon chains. These discoveries revealed that the chemistry needed for life is not unique to Earth. However, Finding such molecules inside distant galaxies is far more challenging. The signals are incredibly faint, and the distances involved are almost unimaginable. The galaxy observed by Webb lies billions of light-years away from Earth. The light reaching the telescope today began its journey long before our planet even existed. Yet within that ancient light, scientists detected the fingerprints of organic chemistry. Specifically, the telescope observed molecules known as polycyclic aromatic hydrocarbons. These complex carbon-based molecules are commonly formed when stars are born and die. They are often found in regions where intense radiation interacts with clouds of cosmic dust. Detecting these molecules inside such a distant galaxy suggests that complex chemistry was already taking place very early in the universe's history. This finding carries profound implications. It suggests that the ingredients required for life may have formed long before planets like Earth even existed. In other words, the chemistry that leads to life might be far more common in the universe than previously thought. But how exactly did Webb detect these molecules? The answer lies in the telescope's extraordinary sensitivity. Webb's large primary mirror collects far more light than earlier space telescopes. Combined with its infrared instruments, this allows astronomers to analyze extremely faint signals coming from distant galaxies. When scientists observed the galaxy spectrum, they noticed specific infrared wavelengths that matched the signatures of organic molecules. These signals appeared as subtle peaks and dips in the light data. Each pattern corresponded to the vibrations of molecular bonds within carbon-based compounds. By carefully analyzing these patterns, researchers confirmed the presence of organic molecules within the galaxy's interstellar dust. This discovery reveals that even galaxies billions of light-years away contain the complex chemical processes needed to produce organic compounds. And that raises an even bigger question. If organic molecules exist throughout the universe, could life itself also be widespread? Scientists studying astrobiology have long believed that organic chemistry is one of the first steps toward the development of life. On Earth, organic molecules eventually combined into more complex structures, eventually leading to self-replicating molecules and living organisms. While the presence of organic molecules does not mean life exists elsewhere, it does suggest that the basic ingredients are widely available. In fact, similar molecules have been detected in meteorites, comets, and interstellar clouds within our own solar system. Some researchers believe that early Earth may have received organic molecules delivered by comet impacts billions of years ago. These compounds may have helped kickstart the chemical reactions that eventually produced life. Now, with Webb's discovery, scientists know that similar chemistry is occurring across vast regions of the universe. Entire galaxies may be filled with the building blocks of life. This discovery also highlights how advanced technology is transforming our understanding of the cosmos. Only a few decades ago, detecting molecules inside distant galaxies seemed almost impossible. But with telescopes like Webb, scientists are now able to study the chemical composition of objects billions of light-years away. Each new observation reveals details about how stars form, how galaxies evolve, and how complex chemistry develops throughout the universe. And this is only the beginning of Webb's mission. Over the coming years, the telescope will continue exploring distant galaxies, searching for the earliest stars and analyzing the atmospheres of exoplanets orbiting distant suns. Some of those observations may even reveal chemical signatures associated with biological processes. For now, the discovery of organic molecules inside a distant galaxy serves as a powerful reminder of how interconnected the universe truly is. Not the same chemical ingredients that exist on Earth may also exist across billions of galaxies scattered throughout space. Hidden within clouds of dust and gas, complex molecules drift through the cosmos, waiting for the right conditions to form new stars, new planets, and perhaps even new forms of life. With every new observation, the James Webb Space Telescope brings us closer to answering one of humanity's oldest questions. Are we alone in the universe? The answer may be written in the faint glow of distant galaxies, carried across billions of years of cosmic history. And as Webb continues to explore the depths of space, the universe may soon reveal even more surprising clues about the origins of life itself.